Within our solar system, the habitable zone is relatively narrow, beginning well outside the orbit of Venus and ending short of the orbit of Mars. If the Earth were just 5% closer to the Sun, it would be subject to the same fate as Venus, a runaway greenhouse effect with temperatures rising to nearly 900 degrees Fahrenheit. Conversely, if the Earth were 20% farther from its home star, carbon dioxide clouds would form in its upper atmosphere, initiating the cycle of ice and cold that has sterilized Mars.
The presence of liquid water is a necessary condition for life, but it's not a sufficient condition. After all, there may be liquid water under the frozen surfaces of Mars and Jupiter's moon Europa, but there's very little chance that complex life exists in either of these places. You see, contrary to what the Copernican principle might suggest, the recipe for life is much more complex than just add water.
If a recipe for a planet capable of supporting complex life really did exist, then what ingredients beyond liquid water might be required? The list of necessary factors continues to grow.
We live on this paper-thin crust. If the Earth's crust were significantly thicker, then plate tectonic recycling could not take place.
The Earth's crust varies in thickness from about 4 to 30 miles. It consists of more than a dozen tectonic plates that are in constant motion. This dynamic geology regulates the planet's interior temperature, recycles carbon, mixes chemical elements essential to living organisms, and shapes the continents. Deep within the Earth's interior, the movement of liquid iron generates a protective magnetic field essential to complex life. If our planet was smaller, its magnetic field would be weaker, allowing the solar wind to strip away our atmosphere, slowly transforming the Earth into a dead, barren world much like Mars.
We need an oxygen atmosphere, and the oxygen-nitrogen atmosphere that the Earth has is necessary for complex life.
As seen from space, the Earth's atmosphere glows as a thin blue ribbon of light. Measuring less than 1% of the planet's diameter, it is composed of a mixture of nitrogen, oxygen, and carbon dioxide. As a result, our atmosphere ensures a temperate climate, protection from the sun's radiation, and the correct combination of gases necessary for liquid water and complex life.
For a size of planet like Earth, our moon is big. The current thinking is that if our moon didn't exist, neither would we.
1/4 the size of the Earth, the moon's powerful gravitational pull stabilizes the angle of its axis at a nearly constant 23.5 degrees. This ensures relatively temperate seasonal changes, and the only climate in the solar system mild enough to sustain complex living organisms.